My depth perception's off there. And you get a nice shot of my stomach. I will try to record the classes, but there's no guarantee on that. So non-zeros are significant, so we're talking the numbers 1 through 9. That should not be a shock that those are not 0. If the fact that 1 through 9 are not 0 is a shock to you, we probably should talk afterwards. So let's start out with the easy one. How many non-zero numbers are there?
3.
All right, so it has 3 significant figures, or 3 sig fig, or 3 significant digits. Any number between significant objects is significant. So, because the 0 is really the tricky point there. So 502, 5 and 2 are not, or sorry, 5 and 2 are significant. Therefore, 0 is significant because it's between 2 significant objects. The reason I wrote objects there instead of digits is that a decimal point does have significance if you were going to write it down. I just realized that I'm going to have to amend one of those things. Oh, no, this is higher priority than that. Okay, I'm good. So, 3 significant digits again. Video, I do that one. How many students have I taught? If I just said I've taught 200 students, how many significant digits is that?
1.
We've got a debate here. Now, the person who said 3, do you want to defend yourself?
Wouldn't it, since there's no decimal, wouldn't it not be a leading 0? Or a trailing 0, I mean?
They are trailing zeros. And if you're going down to that one, trailing zeros to the left of the decimal place is here, are not significant.
So yeah, since there's no decimal, it's significant, right?
Because there's no decimal, it is not significant. They're trailing because they come off, they're on the right side. And it's to the left of the decimal, left being over here. So we're looking at this is the main sentence right here I think you're honing in on.
Right.
All right, so trailing zeros, so zeros off to the left, off to the right, to the left of the decimal place is there. So those zeros to the left of the decimal place are not significant.
Okay.
So
So it would just be 1 sig
Pardon?
fig? It would just be 1 sig fig?
It wouldn't need just be 1. Now, there'll be many times in which one person will have one answer and there'll be many other people with the other answer. The person who has one, the lone voice, please don't automatically assume that you're wrong. I have seen, and you might get the same bit on Wednesday, but it was a 110 lab. There were 4 of them sitting over here working on the lab. They all did calculations. 3 of them got the same answer. 1 of them got the wrong answer. Or sorry, 1 of them got a different answer. And so that one person, instead of defending herself, went along with what the other 3 people had. But that one person was actually the only person who was right. The other 3 were wrong. So do not assume that everyone else knows what they're talking about. So I appreciate your defending yourself. All right, if I wanted to, suppose it was exactly 200 students. How would I indicate the fact that it is 200 exactly, as opposed to somewhere around 200?
0.00.
Now how many significant digits are there? Was it?
5.
Yes, indeed, there are 5 now. Why'd you tack on the 0, 0?
Because you can have a fraction of a number and it'd be still 200, but it'd be 201/4 or 201/5.
Yeah, we're talking about people in this particular case.
So you can't have 201/5, 201/4. You have to have 200.00.
Again, why the 2 0 0? Why not just 1 0?
I don't know. Usually 2 zeros are better than just saying 1 because, breaking up into hundreds is easier than tens.
All right, that definitely would indicate 200, well, considering it's people, Well, let's think about what the numbers actually mean. When I said, if I just wrote down 200, in science, this is somewhere from 150 to 250. We're rounding off to the nearest 100. If I'm rounding off to the nearest 1, so in case of people, it's an exact number of people, I don't need 2 decimal places there. Because now you're going out to the nearest 100th of a person, and I'm not quite sure what 100th of a person is unless there's leprosy going on. I hope no one actually knows someone who's had leprosy. That would just be really horrible. I'm assuming it's gone, in this country at least.
So,
All right, if anyone knows personally a leper, just let me know afterwards and I'll stop my leprosy references. Until then. So let's assume that we are not going down to a fractional people. How would you indicate 200 exactly? Brooke?
What would you normally put like around this, what's it called? You know the symbol that means the like squiggle?
The
that means,
tittle,
like-
the tilde?
Yeah, that means like about 200. So if you have just that, wouldn't that, well, that wouldn't be enough to signify.
Yeah, I mean, if we had the tilde in front of it, that is, roughly 200, but
Right.
in science, we rarely put tildes in there.
Can you just add a decimal there?
Just put a decimal point?
Yeah.
Yeah, just one.
Because the decimal point, visible decimal point is a significant object. We now have zeros between significant objects, so those zeros are now significant. That is one way of doing it, and that's typically the way that I do it. Math textbooks will sometimes underline, saying that that's significant, and other places I have seen put the line over it. I tend not to do that one, especially if we are to the right of the decimal, because that would indicate that it goes on forever, or it repeats. But the underlining is a way of representing an exact number. So this is 200 exactly, whereas that is, plus or minus 50. Or perhaps it is somewhere from 195 to 205. If that were the case, how would I write this? If I'm rounding off to the nearest 10.
A 0 under the second, a line under the second 0.
I was going with the hand gesture. The hand gesture was right. Yeah. Now, another way of doing it is going to scientific notation. It's a little bit easier. I could also write this as 2.0 times 10 to the first, or this one as 2.00 times 10 to the second. And that also will give you the right number of significant figures. Leading zeros, let's see, we got down to, leading to zeros, and that goes left or right of the decimal point. So 0, 3, 0, how many significant digits?
1 or 2. Is it 1?
It's 1 or 2.
It's 1, because it's in the middle.
Yeah, that 0 right there, ignore. Now we get into this number right here. There's nothing to indicate that that 0 is significant. We now go to the trailing 0, so it is indeed just 1. So this is some number from 25 to 35. Questions up to here?
On that 30 example, why is the spread only 5 and not 10?
Because if we were above
It would
35,
change.
it would round off to 40.
Okay, rounding,
Yeah.
okay. Okay,
Is that good?
yeah.
All right. 0.00043. I assume that's your answer, not an obscene gesture? Okay. Oh, was that, you were doing 5?
Yeah, 5.
Oh,
Oh,
We're talking to.
all right, so, was it, you were the one who was doing this to me.
Oh,
So,
okay.
you were saying 2?
Oh, yeah, I was saying two.
Except for the Romans, that would be 5, but, we'll go with 2. Ian, Tyler, I think you were saying 5? Well, one of those two groups is right. 2 or 5?
Two.
What number are we talking about? The decimal?
Oh, this one right here.
Okay.
If you get lost like that, just read my mind. You'll get right back.
Decimal point's
Well,
a
then-
significant object.
Right, and then so is the three.
Right.
But does
So
it count as
five.
the leading zero? Yeah.
There's still
it's only
leading
two.
zeros.
So it's two.
It is indeed 2.
Really?
Yeah. So, because, let's say that this is a unit, meters, that's the same as 0.43 millimeters. It's just a unit difference.
Mm.
These zeros right here are just saying, oh, it's basically placeholders, in a sense. And the reason why you said the decimal is a significant object, and I agree with that, but the leading zero rule takes priority. These are in order, this order for a reason,
Oh, okay.
so that takes a higher priority. Was it?
So leading zeros are
Oh, wait a minute.
the ones that are after the number?
It can be
Yeah.
before or after decimal, right? It doesn't matter.
Right, they can be before or after the decimal, but you're asking before or after the decimal or the number?
Yeah, so, okay, so my question is, so a trailing zero is if it's after the actual number?
Yeah, after the after the significant numbers, those would be trailing. Before the significant numbers, those would be leading.
Thank you.
Okay.
So you're saying 3 is a higher priority than 2? Because if 2 were in effect, it'd be 5, right?
Oh. It is 2,
You see what I'm saying?
yeah, no, I see what
Three
you're
is
saying.
the
I
higher
was going with the fact that making the decimal significant doesn't happen until later.
Oh,
And so therefore, this rule is a priority, even though, yeah, I understand that you will look at significant objects, and down here I'm claiming that
right.
it is a significant object, but,
But not until you get down there.
yeah, not until you get down there.
So what if it was 1.00043? Is that saying that they're all significant
Oh, yeah.
numbers? Okay.
Yeah. Are you dissatisfied still, or, somewhat dissatisfied?
More or less.
Can you live with my interpretation?
Yeah.
Okay. There's a reason I don't care about significant digits after the first
Right.
one. It really came into, I was pushing this with a 251 class, and this person did calculations and had different number of significant digits in there, and I thought, oh, he's wrong, and I started marking off for it, and then I started looking at his work, and the way he did the work, he actually was right, based upon the rules. But if you'd done it a different way, a simpler way, you would have had a different number of significant digits in the end. And I thought, all right, so I went through my anti-significant digits phase. The compromise
Well,
is,
maybe because it's, you know, 0.00043 is a much smaller number.
Can you go over to the last rule, the right point R?
oh, the trailing zeros to the, trailing zeros to the right of the decimal point are significant.
Okay,
So trailing comes after numbers. So is that all you needed? It's just,
just the last one, yeah. Okay, so what, you said it's trailing zeros to the right of the decimal
yeah.
place.
So if I did 0.00430, I'm to the right of the decimal.
Right.
That's the trailing zero. That's
That
significant.
is significant.
That is, yes. The first 3, though, are not, by rule number 3. Ignoring Ray's concern. That's not where you should nitpick.
Okay.
No, I do appreciate that. There's gonna be many times I'm gonna nitpick stuff. Part of me wanted to, on the thing that you just handed in, some of you did lowercase letters, but all the choices are actually capital letters. Uppercase, lowercase makes a difference at some point, not for that, but.
Yeah, okay.
Right.
Yeah, upper versus lower. You start labeling
Yeah.
triangles and stuff.
I mean, there are only 26 letters in the alphabet. We better do uppercase, lowercase. That'll give us 52. Throw in the Greek letters, and we got another uppercase, lowercase, another 50 or so.
4. No, how many Greek letters
I
are
was thinking there was 24.
24?
I could be wrong. Anybody know how many Greek letters there are? It's somewhere around there.
Yeah. I'll say it's a significant of 100, you know, it's somewhere in the range of 150 and 50.
That's right. I think I might be so bold as to go 100, number of letters that we're working with here. I think we can narrow it down.
Yeah.
All right, all right, the other that is, I guess there's a rule 7. In the video, there's a video I do where I leave off, I think I've only got 6 rules there. I'm trying to remember which one I just added. But the infinite significance. So how many people are in this room?
Like 27? 21?
Okay,
22?
thank you.
Oh,
I am
sorry.
human. I am a person. There's 22, and despite earlier claims, there's not fractional people in here. So that 22 actually is an exact number. So if I wanted to figure out how many, that's a horrible example. Let me do it a little bit differently. I have a triangle, an equilateral triangle. 3.4 meters, 3.4 meters, 3.4 meters. And I wanted to find the perimeter. What would I do?
Add them together.
Okay, instead of adding, what else could I do?
Multiply one side by 3.
Yeah, that's the one I was going for. Yes, adding together also works. But 3.4 times 3. If I'm looking at significance here, this has 2 significant figures. And the 3, no. No. It was the word I just used,
Infinite.
3?
somebody just said it.
Infinite.
Michael, thank you. It has infinite significance, because there are exactly 3. Now, how would you indicate exactness? Well, you can't really, because I can't write that many zeros. Or it's not worth my time to write that many zeros. So this 3 is exact, and so what's ultimately going to, for the final answer, this 3.4, these 2 significant figures here, is going to impact how many significant figures in the final answer. That 3 does not, because it is infinite significance. Exact numbers have infinite significance, and that will come into the math bit that we're just about to do.
So if the second number was 30, well, that's a bad example, 31, would it still be 2, or would it be infinite? 'Cause
It depends on the context. So if this were just a straight up math problem, that 31 would probably have 2. If we're talking about a 31-sided shaped object, where each side was 3.4 meters, then that 31 is infinite significance. So context matters.
Okay.
All right, other questions up to here?
Can you give an example of number 5, how there could be a trailing 0 to the left of a decimal?
Of the decimal place, not the decimal itself. The decimal place is right here. Wait, that was, yeah, trailing zeros. So I got a significant number there, and then these zeros come behind it. So these are trailing zeros to the left of the decimal place.
Right. So those zeros wouldn't be significant.
Correct. Was your world just shattered?
Yeah, man. I don't think I ever really understood significant numbers then. I don't know.
It's, ultimately, it's about how much, the level of precision of the answer. You know, I've mowed 1,000 lawns in my lifetime, which is probably low, but that 1,000 is probably not an exact number. It's somewhere about there. That gives me a range, rounded off to the nearest 1,000 if it's everyday speak. So that's the, so all significant figures is telling you what level of precision there was. I don't know if that helped or not, but it's recorded for
so.
posterity.
Yeah.
Was it?
So I have one more example. So if you have like 0.430, then wouldn't the siblings be 3?
Yes, it would.
But wouldn't that go up against number 5?
That is, number 5 is for the zeros to the left of the decimal place. This is to the right of the decimal place. This is rule number 6.
Okay.
And I understand, I don't know if this was the issue just then, the left-right issue, I've had plenty of students in the past who suddenly get left-right backwards, and I will do it occasionally myself, especially since I'm facing this way and I'm talking about the right side. But you good now? At least for the moment. Brooke?
Okay, but you already went over this, but the 0.0043, you said those 3 first zeros, those aren't significant.
Right,
Okay,
they're leading.
Okay, because that goes against the like number 5 rule. Wait, no, it doesn't.
Right.
At the like number 6 where it says trailing zeros to the right,
do those count as trailing zeros?
No,
Okay.
they're not trailing.
Okay,
Trailing is after the significant figures.
okay.
So we're going left to right.
Yeah. Cause 0.43 is the same as, 0.0043 millimeters, or I'm sorry, meters in millimeters, but 0.43 is not the same as 0.00043, hundred. I'm sorry. I don't know why I'm talking.
I did not follow that, but I suspect some of the stuff I've said, you know, some of other people are thinking the same thing about me, so